These are your 12-1 notes on right triangle trigonometry. I'm going to take this one section to review every type of right triangle, trig, Pythag, SOHCAHTOA, 30, 60, 90 right triangles, 45, 45, 90 right triangles, all in one section. So it's sort of everything you did in geometry in an entire chapter, we're going to do an entire day, and then we're going to build off of that. So kind of a review day from geometry. So I'm going to go pretty fast. There's a lot of information, so you may need to rewatch or pause these if I'm going too fast. So everything in this section involves right triangles. So when you have right triangles, we have the Pythagorean theorem. The Pythagorean theorem is built around the idea that you have the sides and the legs of a right triangle. And so if you have the two legs, which form the 90-degree angle, and then the third one opposite the right angle is called the hypotenuse. That is always the longest leg. And then we have points A, B, and the right angle we usually call C. Under that definition, the sides opposite those angles are the little letters. So the side opposite big A, capital A, is side little a or leg A. This would be leg B, and the hypotenuse then is little c. So that's where this definition comes from, that if you square the two legs and add them together, it equals the hypotenuse squared. Another thing we learned in geometry is special right triangles. There are 30, 60, 90 right triangles and 45, 45, 90 right triangles. So there's two different special right triangles. Now when you draw these, it's important that you draw them pretty accurate. So for a 45, 45, 90, you should draw it so that the two legs are congruent. And if you remember, we did little congruent marks. So, but it helps, though, if your picture actually looks congruent. So those two legs should be the same length. If you draw the two legs the same length, then the hypotenuse will fit, and it'll be a 45, 45, 90. We're talking about the degrees inside the triangle. So these two angles are 45 degrees each. You got the 90 degrees. They all add up to 180 degrees. If the two sides are the same, we call them side N. The hypotenuse is n times the square root of 2. That's how long it is. So it's just slightly longer. When you multiply a number by the square root of 2, it's just slightly longer than the other two legs. And so that's how you use the 45, 45, 90. If you have a leg, you multiply by the square root of 2. But if you have the hypotenuse and you're trying to go back to get a leg length, you divide by the square root of 2. So it's just simply multiplying or dividing by the square root of 2, trying to figure out, am I getting the hypotenuse or I'm getting the leg? For a 30, 60, 90 triangle, what I like to tell kids is that make an L first, like a capital L. By making a capital L, the height of the L is longer than when you go horizontally. And so what that does is it creates more of a 30, a 60, and a 90 right triangle. The short side is opposite the 30 degrees. The longer side is opposite the longer degrees, 60 degrees, and then you got 90 as the longest. So small, medium, large. If you have the short side, we can call that n. The hypotenuse happens to be twice that amount, so 2n. And the long side is n times the square root of 3. So again, a lot of multiplying to get the one or dividing to get the other. Everything works through short side. So if I have short side and I need the hypotenuse, I times by 2. But if I have hypotenuse and I need short side, I'll divide by 2. Same thing, if I have the short side and I need to find long side, I'm going to times by the square root of 3. But if it's the other way around, where I have long side and I need to find a short, I'm going to divide by the square root of 3. Notice there's no formula to go over the top. You can't go from hypotenuse to long side. You have to stop at short. So we always work through the short side and then get the other number. There's these things called the angles of elevation and depression from geometry. Okay, it's all about your lines of sight and which way you're looking. So word problems involve these terms. So when they talk about an angle of elevation, it's the angle formed with the line of sight and looking up. And then the angle of depression is when you have the line of sight and then you're looking down. So line of sight, there's actually two lines of sight in this picture. It could be the person in the top of the lighthouse. So this would be the angle of depression. because it's the line of sight looking down to the boat. And then the angle right here with the boat looking straight out across the water and then looking up to the lighthouse, that would be considered the angle of elevation. Now these two angles, inside here and inside here, are congruent angles because they're alternate interior angles. So it's just important if they tell you that the angle of depression is 20 degrees, you got to make sure you put 20 degrees in the right spot. So a lot of your word problems will involve that terminology. Okay, and then another major part of right triangles was trigonometry. So we spent a lot of time doing trig functions. Okay, in trigonometry, the trig is triangle and the ometry is the measurement. So you're studying the measurement of the angles and sides of right triangles. We actually learned the first three trig functions, sine, cosine, and tangent, in geometry. I'm going to introduce to you today three more, and it's just cosecant, secant, and cotangent. At the very bottom of your page, I have the right triangle. It's really important to understand that trig functions are in relationship to the actual angle. So you got to know what angle you're starting from, otherwise this doesn't make sense at all. So I have this little symbol, it's called theta. Theta is just a Greek letter in the Greek alphabet. They want to get rid of using X's and Y's for the angles. They use theta more often. So it's just sort of a step up from geometry. They just bring in the Greek alphabet. So I just want you to understand we are talking about in reference to this angle, that acute angle. There's two acute angles, okay, but when I am talking about side opposite and side adjacent, it's all relative to where you're looking from. So if I'm looking from theta, angle theta, and my line of sight goes across my triangle, that is the side opposite my angle. It's opposite the angle. And then the side next to is called the adjacent side. That's another name for next to or right next to. So adjacent is the one that's touching the angle. And then the other one, of course, is the hypotenuse. So when you talk about opposite and adjacent, you're talking about the legs, and then you have the hypotenuse. So it's always good to label those first so you understand where they're at. Now this is where SOHCAHTOA comes into play. And SOHCAHTOA was just a play on words to help us remember what ratio goes with which trig function. So trig functions are just ratios of the sides of a right triangle. You're writing comparisons. You're comparing one side of the right triangle to another side. Okay? You have three sides to choose from. You're picking two of the three sides to compare. That's all it is. So the SO is for sine, that's the S, and it's telling you that the sine ratio compares the opposite to the hypotenuse. So this is the opposite to the hypotenuse. So you're taking the opposite side and you're writing it over the hypotenuse, and it becomes a fraction. It's a comparison. Cosine, the cosine is the adjacent side over the hypotenuse. And tangent, the T stands for tangent, and the O is opposite over adjacent. So it just tells you not only what two sides you're comparing, which way to compare them. Do you put the opposite on top? Do you put the adjacent on top? Where does the hypotenuse go? That sort of thing. Now there's no other way, there's no SOHCAHTOA for cosecant. So cosecant I wrote right across from sine because it actually does it's just taking the same two sides but actually inverses them. So cosecant is the comparison of the hypotenuse to the side opposite. And secant is just the inverse of cosine. It's the hypotenuse over the adjacent. And cotangent goes along with tangent. It's the adjacent over the opposite side. So they're all fractions. Now, sometimes the book asks you to represent it as a decimal, or your calculator will give you the decimal. But they're all just comparisons. Okay, now I could actually have I could have used the same thing using this angle up in the corner here, but then my side opposite and my side adjacent flip-flop. So depending on what angle you're looking at, changes everything about these problems. So let's go ahead and try these examples. I've got several different examples from here on out. So everything we have all the tools. We just got to figure out what tool to apply. So number one, it asks us to find the value of the 6 trigonometric functions. Well, then I got to write SOHCAHTOA. So I'm going to be using SOHCAHTOA here. Okay, I'll use SOHCAHTOA to find my first 3, and then I'll use my first 3 to find the last 3. So for my sine, now they asked me from angle G. That is crucial, that I'm going from this corner, not F. And just to kind of go over it, you can only write trig functions from the 2 acute angles. We would never be able to write trig functions from H here because it's the right angle. So if I'm starting at G, if my line of sight takes me across my triangle, this is my side opposite. That means that makes this my side adjacent. Sometimes people screw up the adjacent hypotenuse, so you might want to go right from the right angle right away. Always opposite the right angle is the hypotenuse. So now that I have my 24, 32, and 40 labeled as opposite, adjacent, and hypotenuse, I can go ahead and write my 6 trig functions. So the sine of G is opposite over hypotenuse, which is 24 over 40. Okay, and we can simplify that. I can take an 8 out of both of those, and you end up with 3/5. Cosine of G is equal to the adjacent side, 32, over hypotenuse, 40. And I can reduce both of those by 8 as well. So I get 4/5. And tangent G is equal to the opposite side, 24, over the adjacent side, 32. Again, taking out 8 out of each of them, I end up with 3/4. So you always want to simplify your fractions. So now cosecant, which is CSC, that's cosecant of G, is just going to be the hypotenuse over the opposite, but I already did some simplifying here. So I just got to flip that. I might as well take 5/3. Rather than going back to the original triangle, I might as well use the simplified work. So that means that secant G is 5/4, and cotangent G is 4/3. So I know the tangent and cotangent sound the same. These two don't sound alike at all, and they either do the cosecant and the sine. So I try to say that each of them has to have like a C. So if you have sine, you got to have the cosecant to go with it. If you have cosine, you have the C. Now you got the secant to go with it. So you'll get there. It's just a memorization thing. Next problem. Okay, they give us a problem. They tell us that the tangent, they're giving us one of the trig values, and they want us to find another trig value. Okay, I think it helps to have a picture. In geometry, we're always taught to draw a picture if you can. So I don't know if my picture is to scale, but that's okay. It's telling me that tangent A. So I'm going to make this top angle A. Once you commit, now you're committed to where you're going to put the 5 and the 3. If this is the tangent of A, tangent is the TOA. That's opposite over adjacent. So they're telling me that this is the opposite side and this is the adjacent side. So according to A, if I go across the triangle, this is side 5, and my adjacent side here is 3. And what I'm missing is the hypotenuse. Okay? They didn't ask me to find the hypotenuse. They asked me to find the cosecant of A. Well, if I look back at the first page, cosecant is the inverse of sine. So cosecant of A is equal to hypotenuse over opposite. I don't have the hypotenuse. I have the opposite, but I don't have the hypotenuse. So this is where we use some of those other tools. So I don't know if this is a 30, 60, 90 right triangle. I don't know if this is a 45, 45, 90 right triangle. They didn't give me anything about the angles. I have 2 of 3 sides, so that's where we would use Pythag. So a squared plus b squared equals c squared. Notice nowhere on the screen does it tell you you have to use Pythag. That's using your brain, that's using your tools. They're telling you you have enough information to do this problem. You have to fill in some gaps on your own. They're not going to walk you through it. They're going to expect that you understand that this is necessary to answer the question. So 3 squared plus 5 squared. It really doesn't matter A and B when you're doing Pythag, which one is A and which one is B, but the hypotenuse must be the C value. And so I get 9 plus 25 equals C squared. 9 plus 25 is 34, is equal to C squared. Take the square root. C is equal to the square root of 34. And that can't be fixed, so I'm going to label it in my picture. Now I have a hypotenuse. Now I can actually go back to my problem and say the square root of 34 over the opposite side, 5. I look at my radical. I go through all of my radical rules, and it follows all the rules. There's no perfect in there. There's no fraction in there, and it's not in the denominator. So that problem's finished. Okay, in this problem, a couple clues that I can see. I'm missing a side measurement. I'm just going to kind of walk through my thinking process. I would love to use Pythag because it's one of the easiest tools, but I can't because I only have one side measurement. So Pythag works when you have 2 out of the 3 sides. I do see a different clue though. They're giving me that this angle is 60 degrees, which means this top angle would be 30 degrees. So I have a 30, 60, 90 right triangle. So what I could do is I know I have to find the long leg, but I could work through short leg to get there. I have the hypotenuse. So if I take 12 and I divide it by 2 to undo double, that gives me the small side, 6. And then to get long side, I just multiply that 6 by the square root of 3. And so x is equal to 6 root 3. I use special right triangles there. Now, special right triangles are great, but they require a lot of memorization. So if you don't understand what just happened there, there is a better way. You can use trig. Okay, I have an angle. I have 60 degrees. I have the side opposite 60 degrees, and I have the hypotenuse. So looking at opposite and hypotenuse, I'm looking at the sine. So if I set up an equation that says the sine of 60 degrees is equivalent to the opposite x over the hypotenuse 12, I've just written an equation, then I can solve for x. Sine 60 is a ratio. Sine 60 is a ratio of the sides. Your calculator has every sine, cosine, tangent of every right triangle programmed in those buttons. So to solve for x, I'm going to times both sides by 12. Whatever I do to one side, I'm going to do to the other side. And so x is equal to 12 times sine 60. So at this point, you want to make sure your calculator's in degrees. We can go over that in class. The sine of 60 times 12. So I'm actually going to hit sine 60 first, hit equals, and then times 12. And you should get some ugly decimal, which is fine. And I'm just having some, so we'll try that one more time. Sine 60 times by 12, I get 10.39, so 10.4. So if you use trig, I'm okay with a decimal approximate. If you notice though, if you type 6 root 3 in your calculator, this exact value I got using special right triangles, and you take, it should equal 10.4. So those two values are equivalent. All right, so you had a couple options there. In example 4 here, they're asking us to solve the triangle. What it means to solve the triangle, it means to find all the missing parts. And so what's missing here is I'm missing this angle, angle y. I'm missing side x, and I'm missing side little z, or the hypotenuse. So I'm going to find angle y first. I've got a 90-degree angle. I got a 28-degree angle. I know that triangles add up to 180, 90 of which is here. So the other 90 make up these other two angles. So to find the measure of angle y, I'm going to subtract 28 from 90, and I end up getting 68 degrees. That's the easier, I'm sorry, 62 degrees. Easiest way to find that angle. Now, I can use that angle, but here's the problem with using one that you found. And sometimes we don't have a choice. If you use an angle that you find, what if it's wrong? Then everything that you find after that is wrong. So let's just stick with the 28, stick with what we're given, and the 11. So to find x, I'm going to use the 28 degrees. I can't use Pythag because I only have one leg here. I cannot use special right triangles because it's a 28-degree triangle, not 30 or 45 or 60. So I have to use the 28. So in terms of 28, side x is opposite. And 11, since I need a number because the x is my adjacent, and since I'm labeling everybody, I might as well label this as the hypotenuse. So I actually can't use sine here because if I use sine, I'll have an x over a z, and that doesn't help us. So I'm going to use the trig value that takes the opposite and the adjacent values. So I can have the x and the 11. TOA is the trig value, or tangent is the trig value that I need. So I'm going to do tangent 28 degrees is equal to the opposite x over adjacent 11. This is one great big fraction or decimal, so keep it, it's a number. Tan 28 is a horrible decimal. Leave it as tan 28 until you have to use your calculator. And times by 11, times by 11, x is equal to, I'm going to put it in my calculator, tan 28 equals times 11, 5.84. So 5.8 is just fine. It's just an approximate. So x is equal to 5.8, and then I need to find z. So I'm going to use my adjacent and my hypotenuse. That's cosine of 28. So I'm going to use cosine 28 degrees is equal to adjacent 11 over hypotenuse z. A little bit different, the variable's in the denominator. When that happens, I got to multiply both sides by z. It cancels here, shows up over here. So now what I have is z times cosine 28 is equal to 11. Cosine 28 is just some awful decimal, so divide both sides by awful decimal, cosine 28. So all it does is it changes the order in which you push the buttons. We are not going to be multiplying 11 and cosine 28. We're going to multiply or divide 11 by cosine 28. So 11 divided by cosine 28 is equal to 12.5-ish. Makes a big difference how you calculate that. That is not the same thing as dividing by 11. So it's really important that you take your time and show your work there. All right, we're going to skip this one. Well, I might show you, actually this one's not that bad. We're missing the angles. So to find an angle, if I want to find angle A, I would love to use subtraction, but I can't subtract because I only have one angle. So once I find angle A, I can find B using subtraction like we did before. To find angle A, I can use any one of these combinations of numbers. I can use any one of my sine, cosine, or tangent functions because I have all three available to me. So if I decide to do sine of A, I don't have the degrees, A degrees, but I do have the ratio. The sine of A degrees would be opposite over hypotenuse. So that would be over 9/17. To undo the sine, I have the sine. I'm looking at it right there. The sine of this angle is 9/17. I need the calculator to figure out what the angle is. So if I say the inverse sine of 9/17, if I take the inverse of it, it will equal A. So that's what I need the calculator to do. So I'm trying to undo the sine. I'm trying to ask the calculator, what is the angle? If I give you the sine, will you give me the angle? So this is where we hit our second sine value and then put 9 divided by 17 inside parentheses. And that's a 31.9. We'll round it up to the nearest whole, 32-degree angle. So angle A is 32 degrees, which means that angle B is the 90 degrees minus 32. And notice I used 90 because I already have 90 in the corner, so the other two angles make up the other 90. So angle B is 58 degrees. All right, last problem. I'm not going to go through this problem, I'm just going to set it up. It's a word problem. A spring breaker is parasailing at an elevation of 47 degrees. So there's that elevation The length of the tow line is 500 feet. How high above the water is the teenager parasailing? So if you have this right triangle formed here, there's my right triangle. It's parasailing at a height of elevation of 47 degrees. So elevation means up. This is a 47-degree angle. The tow line is 500 feet, which means it's the hypotenuse because that happens to be the line that attaches to the parasailer. And then how high above the water is the parasailer? So what are they asking for? They're actually asking for that length there. But every word problem is different. So the problem with word problems is you got to make sure you put the stuff in the right spots or it's not going to work out. So in this case, I'm going to use 47 degrees. I'm going to use the side opposite and the hypotenuse. So side opposite over hypotenuse is sine. So sine 47 degrees is equal to x over 500. That's what you would do there. Part B says a great white shark can jump out of the water 20 feet. So at what angle of elevation is a teenager in danger? So what they're saying here is if you got a 500-foot tow rope and this happens to be 20 feet, right? We want to be above 20 feet. What angle should we keep this at? So now you're looking for the angle. So if I had 20 and I had the feet, and to find the actual angle, I would have to do the inverse sine. So this is where we would do the inverse sine of 20 over 500. And that's how you'd figure that one out. Okay, so for summary, find the length of MN in the triangle and find the value of x. So we're going to work backwards to find the degree and find a side measurement. Good luck.